very, very old AI. Like before AI was a thing, somebody made this program. And we're gonna read this and then you guys can find the link in your Google Classroom. I posted it yesterday because I've been that on top of things. Look at me go. Actually, I was afraid I wasn't gonna be able to find it. And then I didn't want to like wake up at 3 a.m. with a pit in my stomach that I couldn't find it. So that's why I did it yesterday. Anyway, okay. Computers mimic human reasoning by building on simple rules and statistical averages. Test your strategy against the computer in this rock, paper, scissors game illustrating basic artificial intelligence. Choose from two different modes: novice, where the computer learns to play from scratch, and veteran, where the computer pits over 200,000 rounds of previous experience against you. Okay, that link right there is the one that I posted in Google Classroom. So you can just go to Google Classroom, click the link, and it's going to bring up a game. And click novice first. There would be novice first. It says use a random number table. Okay, we're not going to do a table. We're going to do graphing calculator. Technically, though, if we want to be, fancy about it, we could say that a random number table lives in your graphing calculator because it does. So technically, we're using a random number table. But anyway, we're gonna use the calculator to determine whether you will throw rock, paper, or scissors against the computer on novice and veteran both. You will conduct 30 trials for each expertise level and record the outcome of the game as win, loss, or tie. Okay, so step one, question number one is a chapter 4 question. And let's remind you how to list what you're going to do for a random, and we're going to go. We're going to change that word from table to generator. And again, technically we're not cheating because a random number generator is just using a random number table inside of it. Anyway, making a note, doing some AP exam review. Okay. Does it make sense to you that rock, paper, and scissors has 3 outcomes? Okay. And does it make sense that we want to assume that they're equally likely? Okay. So I'm going to say let 1 equal rock, 2 equal paper, and 3 equal scissors. Everybody okay with that? 1 is rock, 2 is paper, 3 is scissors. Also, my hands are freezing and it's really hard to write. I don't know if anyone else is having this struggle. Okay. Okay. Now let's just pause here. Does this make sense? So graphing calculator person is going to put this in the calculator. I'll remind you how to do it in a minute. So I'll talk to the graphing calculator people in a second, whoever that person is in your group. And that person is going to hit enter. And if they say, if it's 1, they're going to tell you to click rock. And if it's 2, they're going to tell you to click paper. And if it's 3, they're going to tell you to click scissors. And then you're gonna say that to the person who's operating the Chromebook. And that person is gonna hit rock or paper or scissors, depending on what you say. Does that make sense? Okay, and we're gonna repeat that 30 times. We're gonna do 30 times on novice and 30 times on veteran. Now, we're gonna play with this before you start collecting your data. There's also something you need to keep in mind with this before we start. You have to note what round you obtained your first win. And it keeps track for you. I don't know if you've been playing with it. It keeps track for you, but I don't know if you get down to 30, if your first ones disappear. So we just have to be careful. Anyway, and then we just need to record whether or not it gave us a win, a tie, or a loss. Okay, if the AI is working, that means that your wins should reduce over time. If it's learning, does that make sense? If it's not learning, that means that they should be equally distributed. Okay, so let's pretend, we're just gonna do a trial run here. So graphing calculator people, hit the math button, scroll over to probability, and number 5 on mine. I don't know if it's number 5 for everyone. Rand int. Hit enter. You want the lowest number you get to be a 1, the highest number you get to be 3, and you're just going to do one at a time for sanity purposes. We could do all 30 at once, but sanity purposes, we're going to do one at a time. Does that make sense? Everybody good so far? Okay, so if I hit enter and then hit enter again, that would be a scissors. Everybody clear that that's a scissors? Okay, and then you would say, okay, to my Chromebook person, I got a scissors. And so the person with the Chromebook, by the way, hit novice if you're first in there. The person with the Chromebook is going to hit scissors. And then it will tell you that you got a tie. Okay, now don't be worried if you don't see that it was a tie in the 2 seconds that it gives you the word tie. It tells you that it's a tie right here because we both had scissors. You can see the little hand doing scissors. Okay, so if you have 3 people at your table, this is optimal. You can do it with 2, but somebody needs to be operating the graphing calculator, somebody needs to be operating the Chromebook, and somebody needs to be recording how many of each that you get, with a total of 30 in the novice and then 30 in the veteran. And then once you want to start over, you just hit refresh and then hit veteran. Does that make sense? Yeah. Okay, but here's my question. Can you do this 30 times? Will it save all of your, can you see it all? Or will it go away? Let's pretend we got all scissors. I don't know if I have time to do this. I think do tally marks like you're, counting down your days of school that are left. Do you know what I mean? Just to have one person off to the side making tally marks, just make sure that you have a total of 30. Also, can you guys tell from my screen? Take a look at my screen real quick. Round 1 and round 2 were tied. Round 3 was a win because the human won and the computer lost. And then round 4 and round 5 were losses. You see the little green check mark shows you who won and who lost. Okay. All right. So go ahead and collect your data. Have fun. The fun part. Also, watch how the computer learns. It's actually pretty cool. Okay. We just, let's do it
Yeah.
again.
Okay, so it's by math. And then you go
Tell me if don't forget to write down in what round you obtained your first win. You guys should. Do you know what I mean? What's the first time that you got a check mark on the left side? If you're very careful, you could just keep going until the boxes add up to 30. But I'm scared that something's gonna happen, so. All right. And then you got paper again. Then we got paper again. No, it's okay. So we got paper again, one more time.
Or if you go way too long, they're gonna go.
We got, yeah, raw, no paper. And then we got. Wow. I'm not doing it, in fact,
You are a
then we
troll.
got digital. We got.
Rock.
And then we got. Rock. Oh, there it is. Okay, so you guys look at mine up here. I have my 30 rounds, 12 wins, 7 ties. No. Yeah, 12 wins, 7 ties, 11 losses. What? Mine's even. I don't know. Okay, but I represented that here in my table. 12 wins, 7 ties, 11 losses for a total of 30. When you get to that point, okay, then hit refresh. And then go to the veteran mode and do the same thing.
So, fine.
Ten wins, 11 ties, and 9 losses. 11 calculated, so they didn't know who you are.
You're gonna give us some bad call out. We have to vote for this thing.
Alright, so we got two. And then we got three. And we got one.
Alright.
And then we got one. And we got one. There is random. So we got three. And we got three. We got three again.
None of them even had it. They're all there. So it says rain clouds.
We got three, yeah, which one the four? That one was yeah. And then we got three.
You're not allowed.
Okay. Hopefully you guys are close. The next thing I need you to do is find the total of your three columns, so find your total wins, total ties, and total losses.
Oh my God. You don't stick your photos. I feel bad because I didn't learn what it was. Yeah, that's the bug on there.
Okay, sounds like you're ready. Flip the page over, please. Okay. Julie, Random game of rock, paper, scissors would result in a statistical tie with each player winning time and losing one third of the time. However, people are not truly random and thus can be studied and analyzed. While this computer won't win all rounds, over time it can exploit a person's tendencies and patterns to gain an advantage over its opponent. This is why we are using a random number table, not really a table, however that it is. Test whether the computer output is truly random, regardless of the mode, using a statistical hypothesis. Use alpha equals 0.6. Okay. So they didn't really tell you, but when it says regardless of the mode, it's asking you to use the totals. Okay, so let me say, when it says regardless of the mode, it's asking you to use just the totals. Okay, and so I want you to narrow your focus to your totals and tell me, is that a list or a table? Your totals, just your totals. Is that a list or a table? It's a list. It's a list. Okay, and so I'm going to ask you to find this. This is your 12.1a notes. 12.1a is where we learned chi-square goodness of fit 75 weeks ago. No, just kidding. And this one is a list. That's why we're using goodness of fit. And it says we can do some different stuff for our ho and hot. It says the distribution of wins, losses, and ties is the same as the claim. That doesn't really make sense here. What makes more sense to say as a null hypothesis in this case? Something like winning, tying, and losing occurs 1/3 of the time, or occurs equally. Winning, tying, and losing occurs equally, or is distributed equally, or something like that. I would just copy off of this. What if you said, winning, tying, and losing is truly random? I think that works too. So there's a lot of options. Unfortunately, children don't like options. You know, Mrs. Talbot doesn't really like options either. She just wants to be told what to do. And so, but this is not a contrived math problem. Okay, so let's say All right, so I'm gonna look back at my notes because it's been several hot minutes. And my notes say that in the plan, I say chi-square goodness of fit. I check for randomness, 10% condition, and all expected counts greater than or equal to 5. I can't remember what that means right now because it's been so long, but we're gonna figure that out second. That's actually a lie. I do know what it means. I'm just saying, if I were you, I probably wouldn't remember. So random. We see the word random all over in this thing. But if you remember when we did trash get ball, we said assume that whatever amount of throws was a random sample of all throws. So okay, in this case, throwing means throwing rock, paper, or scissors with your hand. That is the actual correct term, or throwing rock, throwing paper, or throwing scissors. I know it's kind of scary to think about throwing a rock at your friend, but actually maybe not as scary as this is. Anyway, cool. Does it make sense why I'm using 60, by the way? Okay. So I'm hoping you guys are picking up on the fact that games, usually you say something about assuming it's a random sample. I can picture someone doing this 600 times. Sure. I mean, even today, if I just have 10 groups, right? Okay, now what I'm hoping is that this is true. The large counts condition for chi-squared is all expected. I'm sort of writing this prematurely. Are greater than or equal to 5. Just gonna hold off putting my little check mark there. Okay, and then I'm going to remind you how to find expected counts for chi-squared goodness of fit. Okay, the first thing I'm going to do is transfer my numbers from the totals at the bottom. So I have, don't put my numbers, put your own numbers. These are your totals. 25, 13, and 22 for a total of 60. It's the numbers I asked you to add up at the bottom, the totals. Everybody found theirs? Okay, so expected counts, the total observations n times the claimed proportion for that category. Okay, so the total observations times the claimed proportion for that category. We said we claimed that it was 1/3 of the time. Or you could just be reasonable and put 20, 20, 20, yeah. I wrote 60 and 1/3. 60 and 1/3 is very different from 60 times 1/3. Okay, and now I could go back and put my check mark because they're all greater than or equal to 5. In this problem, it really makes sense to just do it by hand. But you can do it in L1 and L2 if you like. It's up to you. We have to write the first two and the last one of the chi-square statistic anyway. So, all right. So, observed minus expected squared over expected plus observed minus expected squared over expected. Oh. Okay, graphing calculator person observed into L1, expected into L2. Stat tests scroll up to chi-square goodness of fit. Stat tests scroll up to chi-square goodness of fit. What are my degrees of freedom in this problem? 2. Do you know where that came from? Categories -1. Like win, tie, loss is 3 categories. Don't write down my stuff. Don't write down my. Yeah. That's unsatisfying. Yeah. Minus. Yeah, it means it was evenly distributed. Yeah. It means you failed to reject. So apparently it's got to be really, really off. I think the problem is the degrees of freedom is so low. Last year, my p-value was 0.45. I don't think anyone in my class rejected the hoe last year. Did anyone reject the hoe? I'm jealous if you did, but no, alas. it'd be really upsetting for me if I created this AI and then it just worked out for you and went there. Yeah, I feel too. Pretty sure. You would be excited then, because your AI worked. Yay, mine did not. Okay, anyway. Any questions about Chi-Square Goodness Assistant? So the one thing I wanted to remind you of here that I figured you forgot is how to get the expected. And you take the total times the proportion for each category. They do not all have to be the same. This one is actually a special case because usually we gave you a percentage for each one and you calculate that. But it's really important that you use the total times the percentage, not the number in the spot times the percentage. That would be bad. Total. Okay, flip the page. Okay. It is, and we're gonna get through the top of here. Then you guys are going to do number 6. And I'm gonna help you get the hoe started for number 7. You're gonna do number 8, and then the whole page 9 is just for fun and optional. Okay. So this is not unit 4 for our book. This is unit 6. This whole page is binomial and geometric. And you need it. I'm sorry to tell you, you all need to review this. Bless your hearts. Okay. Whether you want to do it the day after spring break or not is a different question, but we all need to do it. I'm going to grab my yellow sheet out. You can grab yours if you want, but you don't have to. We can just go with mine. Assume that the probability of you winning was purely theoretical. Answer the following questions. Unit 6. Assume the conditions for the Bernoulli trials are satisfied. Please do not worry about that. That just means determine that we found the conditions for it to be binomial or geometric. So there were conditions for that. Equally likely, like success or failure, probability the same for each trial. Just assume that that's all set. How many rounds would you expect to have to play until you obtain your first win? How many rounds would you expect to have to play until you obtain your first win? Okay, so first, the word first, is that binomial or geometric? This is why you need it. What's the difference between binomial and geometric? Okay, here we go. 6.3a. Requirements for a binomial distribution. Fixed number of trials. Independence. Same probability for each trial. Success or failure. Okay. However, geometric. Requirements for a geometric distribution. Success or failure. Independent. Same probability for each trial. First success. Let me ask you again. Is it binomial or geometric? Geometric. Okay. Okay, now this word expect is actually on your formula sheet. So if you remember, the mean is the expected value. And this is the formula for expected value of a geometric. Expected value is 1 over p. What's the probability of success in this particular problem? That's a probability of a win. 1/3. So you would expect to have to play 3 rounds before you obtain your first win on average over time. That makes sense, right? Just like common sense. How many rounds would you expect to win out of 15 trials? Binomial or geometric? Binomial. Look, you got a number of trials now. Oh, it's coming back to you. Look. Okay, now expect means the mean. The mean of a binomial is n times p. Okay, what's n in this problem? 15. P is 1/3 for win. What's 1/3 for everything? So that makes sense. If they're 1/3, 1/3, 1/3, then you would expect to win 5, lose 5, and tie 5. Okay. How many rounds did you have to play until you obtained your first win? This is just a number that you get off your front page. For me, it was three rounds until I got my first win. So just take that number, write it there. That's it. Yay, that's my favorite question of the whole thing. Number 4. What is the probability you would obtain your first win on the round that you did? So for me, that's the 3rd round. Write whatever yours is right here. Okay, binomial or geometric? Geometric. Okay, now you probably forgot, but Geomet PDF is when it's exactly a number, and Geomet CDF, it's when it's less than or equal to. These two are both exactly, so we only have to worry about Geomet PDF, which is good because you're dipping your big toe back into chapter 6 right now. So right here, probability, for me, I'm going to put x equals 3. You guys put whatever number you have from here. Equals Geomet PDF. And what does Geomet PDF even want? I forgot. Mrs. Talbot, not only did I forget what we're doing now, but I forgot what we did in December a lot. I didn't actually. It was December. Okay, and Geomet PDF asks for 2 things. It asks for your probability of success, and it asks for on which round would you get your first success. Probability of success for us is 1/3. And for me, it would be on my 3rd round. But you guys should put whatever number here that you have for your problem. And just type 1 divided by 3 right there. Don't type 0.3 or 0.333. No, we're not doing that. Oh. So me getting my first win in the 3rd round was not unusual. What round did you guys get your first win? First time? 3rd? Same as me? 1st? 2? Notice how they're pretty much all between 1 and 3, because that makes sense. Okay, last question for this page. What's the probability that you obtained the number of wins out of 60 total trials that you did in either mode? Okay, so 60 total trials. Binomial or geometric? Binomial. And take a look and see how many wins you had. I had 20, it's this number right here. How many total wins you had? I had 25. And what does Binom PDF want? Okay, so number of trials was 60. Probability of a win was 1/3. And I want to know about 25. Oh. Pretty unusual. Okay. Flip the page. By the way, I have plans to reteach you two things, one of them being probability stuff from chapter 5. The other is to go over PDF and CDF for this again. I will do a reteach for that after we're done with chapter 12, but because it's not something we do every day. Okay, was the novice mode actually easier to win? Test whether there is an association between the level of expertise and the outcome of the game. Okay. Now, this word right here should tell you that you're going to do a chi-square test of association. Okay, and we're just going to do the whole and the ha together so that you can get started. And then I'm going to tell you that this is 12.2b notes. Then you're going to finish this problem for homework. Okay, so 12.2b says that for the state, you say there is no association between blank and blank. And for the ha, you say there is an association between blank and blank. Okay. And do you guys understand level of expertise means novice or veteran? Okay, this is the one where you're going to use the matrices in your calculator. And the really big thing I want to tell you is that this is all well and good, but for this problem, you have to look at this as a two-way table now. Does that make sense? So you're not just looking at the totals. You're going to put 12, 7, 11, or whatever you guys have, 13, 6, 11 in matrix A. And then in matrix B, you're going to do row total times column total divided by total total. Row total times column total divided by total total. If you need to look back at the 12.2b video, it is posted for the calculator portion of that. Okay, type 1 or type 2 error, I'm going to let you fill that one out tonight. Okay, flip to number 7. Number 9, put the word optional up here. You do not have to do this page. This is just for fun and practice later if you want to. Okay. If both you and the computer use randomization and statistics instead of psychological influences as human behavior to calculate, the distribution of the outcomes should be the same despite the level of expertise. Is the outcome of the game distributed the same for novice and veteran mode? Use alpha equals 0.10. Distributed the same. Distributed the same. Tells you that you are doing a test of homogeneity. It's the other one. There's 3 of them. So, okay. And this is the 12.2a notes. Luckily, the expected counts and the observed counts are going to be exactly the same from the previous problem. So the do step, you really only have to do once, which will lower your amount of work. Okay. The state is there is no difference in the distribution of blank. There is a difference in the distribution of blank. Okay. I have a feeling this one's going to come out very similar to the one that you do right before this one. On this one though, you have to treat the two different levels of expertise as 2 separate random samples. So on this one, you're gonna say n equals 30, n equals 30. On the other one, you're gonna go n equals 60. I think that's pretty much the only difference. Look, I did it. I ate out. But I did it.
Just the ones you added.